conceptualized well fluid operated jam pump for remote offshore application, etc. May I now request Mr. Fanijati Sharma sir to kindly take over the session. Thank you and over to you, sir.
Thank you very much. So I will straightway go to the presentation, and just a little bit correction. Currently, I am working with a company called Swasco in Oman, Muscat, and I am now presenting from Muscat actually. And sorry, and pardon me for the background, because today is being Friday. I am not in the office. I am just working from the hotel. Yeah. So now I need to share my presentation. How do I share it? Is my screen audible, visible?
Yes, sir.
Okay, so my whole screen is visible. So I will, okay. So my topic today is the well intervention operation. And before going to the well intervention operation, I would like to do a little bit of concept review. So how a well looks like. Just a minute. I would like to have a pointer. All right. So in order to produce from the formation, we need to drill through the formation which is far away from the ground. So we are drilling a well in various phases, like, you know, in a tapered type. So one section of hole is drilled and then casing is landed and cemented. That is the first section. You can see this is a surface casing. Then second section is drilled through. The intermediate casing is landed and cemented. And finally, the production hole is made and the production casing is lowered with a cementation. This is, I'm talking about only 3-stage drilling. It may be 4 stages, or depending on the requirement or depth, lithology, everything, that design would be changing. Probably it could be even 5 stages or more. So, and finally, to produce the formation fluid, we need to lower the production tubing, which we call it completion. So this is the production tubing. So this is the component of the well underground. And the overground, you can see that casing head and the Christmas tree. So the Christmas tree looks like, you know, similar to this, having 2 master valves generally, one flow wing valve or production wing valve, and to which through a surface choke it is connected to the production facilities. There is another valve. Sometimes it may not be available in all the wells. Sometimes it is available. This is a killing valve. It helps in killing the well whenever it is required. And the swap valves. Swap valve is installed so that the well can be intervened with different well intervention equipment through this valve. And what you see generally, you see in an oil field from the surface is something like that, which is the Christmas tree is above the ground. Or sometimes you can see towards the right hand side, it's a beam pump. Actually, it is an artificial lift beam pump installed on the top of the well. So these kind of things you can see from the surface. So when I talked about the completion, because well intervention is always linked with the well completion. So when you talked about the well completion, there are 2 types of well completion. One section is called the reservoir completion or lower completion, which you can see towards the bottom side. And the top part is is called the upper completion, which is the tubing jewelries with a different equipment. It sometimes subsurface safety valves, sliding slips doors, packers, ESPs, some landing nipples. All depends on the requirement or what is the purpose of the well. Based on that purposes, this completion well completion has been designed. The lower completion, generally you can say lower completion could be the barefoot completion, or sometimes barefoot completion is done where the formation is very solid, there is consolidation is very good, or sometimes in the basement. Then the lower completion could be the pre-drilled slotted liner in order to avoid the collapse of the formation. And most general completion type is the cemented completion with a perforation. And sometimes whenever there is an unconsolidated sand, then you need to do some sand control completion with the lower hole against the formation, and that is called the open hole. Sometimes it could be open hole sand control, which could be screen or gravel pack, or it may be cased hole gravel pack if the sand ingression is identified later after completing the well with the cemented and casing. So these are the general types of the lower completion. Now, I will go through the well life cycle. The well life cycle consists of four main components. One is the design. So based on the purposes, based on the formation lithologies, formation characteristics, what kind of fluid we are going to produce, or sometimes we may go inject some fluid like water, polymer, whatever it is. So the design is the first phase of well life. Once the design is done, then comes the second phase, which is construction phase. Construction phase is the drilling phase basically. So well is constructed with a rig, drilling rig, along with it is completed. And then the next phase is the production phase. And the production phase is the longest phase of a well life. And because of the production, it is the longest phase, and well is getting produced for different circumstances. The well needs maintenance, and because this maintenance could be the production sustenance, maintenance could be production enhancement, or maintenance could be the well health maintenance. So in order to do the maintenance of the well intervention is being carried out, and this could be workover, or it could be light well intervention with different equipment. And then when the production phase is over, that means well is no longer capable to produce, or there is nothing, then the final phase of the well is coming as an abandonment. So that we need to abandon the well in a proper manner and restore the surface and the ground. So these are the four phases of well life cycle, and the well intervention will be happening during the production phase. So well intervention operation predominantly divided into two types. One is heavy intervention. So heavy intervention is always done with the rig based, with deploying a rig, which is called workover rig. And the light intervention. The light intervention is rigless. So rigless intervention is done with the coil tubing unit, with the electric line unit, a slick line unit, or sometimes with the some pumping unit. So these are the two broad classification of well intervention. Now coming back to the well workover. So well workover is a rig-based intervention, and in this picture you can see a cross section of the formation where you can see the caprock various zones, formation zones, and the well cross-section has been depicted. So the well workover is carried out either to enhance the production or sustain the production, or to sustain the injection. So the few of the well workover types could be the zonal isolation. So if we have to isolate certain zone because of low production or the water ingression or some other reason, then we need to isolate the zones if there are multiple zones encountered or produced completed against this well. Then it could be zonal change out. The formation treatment, the formation over a period of production, the formation is getting plugged up. It could be the production skin, or it could be some injection skin also. So formation needs to be treated. Then the water shut off is another type of well objective to in order to carry out the well workover. Sand control over a period of time. If we initially, sometimes a lot of wells are not completed with sand control mechanism, but over a period of time we encounter that well is producing sand. So we need to install certain downhole sand control equipment. So that is done through the workover operation. Then additional perforation can be done. Artificial lift, another objective of well workover, because maybe sometimes at the beginning the well sustains the natural production, and after a period of time formation pressure declines and it cannot sustain the vertical lift. So in order to assist the vertical lift, we need to install the artificial lift. So these are the broad sense the activities carried out for enhancing the production or sustenance of the production, or injection to maintain the injection performance. The other type of workover is done to repair. Now, over a period of time, when the production is happening, there are a lot of corrosive fluids also getting produced, and so because of the wear and tear, the completion jewelries, the lower completion, the upper completion jewelries get damaged. So we need to repair to maintain the productivity of the well. So the other objective of the well workover is the repair. So barriers and envelope needs to be repaired. So the type of the workover could be the cement repairs. If the cement gets failed, then we need to repair the cement. Completion replacement, either could be the upper completion replacement or could be the lower completion replacement. The packer is failing, the tubing getting leaked or tubing getting corroded, so needs replacement. So you need to do the workover. Sometimes wellhead needs the rectification. Some leak has happened in the wellhead, so this needs to be rectified. Then casing repairs, even the lower completion repairs. These are the activities done with the help of the workover unit to repair and maintain the health of the well. So the workover can be classified into two main objectives. One is to enhance the production or the injection performance. The other is the repairing. So equipment fails. This is the completion picture, which is depicting the lower completion and the upper completion. So what happens at the design phase? As I said, during the well life cycle, the initial phase is the design phase, and in the design phase is based on the well data collected during the exploration phase or the appraisal phase, or sometimes even the development phase. So what happens, particularly in the exploration phase or the appraisal phase, all the information may not be available, and there is a likely chance that design is made, but that may not sustain or completely compatible with the fluid that is going to encounter during the life. So equipment may fail in the process. So equipment failure happens due to the effect of pressures, thermal stress, because this formation is down deep and the geothermal gradient is if you see that at the depth, it is temperature is very high, and while producing, the produced fluid also getting heated, even though the heat is getting transmitted, but still this heat is the thermal stress is developed in the completion, maybe in the lower completion as well as the upper completion. So equipment fails sometimes because of the thermal stress. Corrosion is another aspect. Formation fluids consist of some corrosive fluids like hydrogen sulfide, carbon dioxide, and sometimes while treating the well, we use some corrosive fluid like acid. So the equipment fails because of those corrosion. Then applied or induced mechanical loads, because we are doing a lot of activities including pumping, so additional load has been applied, and because of that also the equipment may fail. And if the well is getting produced with the sand, then sand erosion happens, and these are the predominantly cause of the equipment failure. So it is very, very important to distinguish the two types of failure. One is the catastrophic failure, and catastrophic failure means it is a safety concern. There is the envelope or barrier failure, so it needs immediate attention and immediate workover. And there are other types of failure, inability to function with no immediate safety concern, like we are having a gas leak valve failure, or the Packer failure. So that may not lead to immediate safety concern. So that may take time to decide when, suitable time when to intervene. But these are the two main aspects. One is the directly having the safety concern, because if those concerns are not addressed immediately, there would be a disasters, the environmental effect, and a lot of waste will be generated in the process. And typical component failures are tubing or casing failures, the downhole packer failure, failure of flow control device, because there are a lot of flow control devices are installed in the completion, like subsurface safety valve, sliding sleeve, or the nipple profile, nipples. So there are a lot of flow control devices are installed, and if there are failure, those are the equipment gets failed, so needs to work over. Wellhead and Christmas tree. Sometimes wellhead is having the failure, it is having leak, or it is getting corroded. Christmas tree is getting needs to be repaired or replaced. Sometimes the hanger seal getting damaged. Then in case of artificial lift system, it could be, there are various type of artificial lift. It could be downhole pump failure, so you need a workover. Gas leak valve failure, you need a workover, or you may not need a workover, you need an intervention basically. We'll talk about this later on. And sand ingression, sand control failures, example, the skin might fail, the gravel pack might fail. So these are the typical component failures in the well life. And you can see some of the pictures, like the left hand side pictures is showing that tubing getting corroded because of the this is from the injection well basically. In another picture, the tubing is getting collapsed because of induced pressures, induced load. Sometimes in the process of going to perforate a well, accidentally the perforation happens in wrong places, and that also causes a failure, and you need to do the workover. So this is the picture is showing accidental perforation in the tubing itself. And there are another type of failure, like you can see they are dual completion. You might be knowing sometimes the well is completed with dual string. One string is produced completed to another a particular zone, and then another string is completed to another zone. So you can simultaneously produce without commingling the production. So in the process of putting the dual completion, sometimes the tubing while running in hole, or due to the pumps and all, there are failure happens, and you can see the twisted tubing got twisted. And all these things, whatever I have shown in this picture as the failures or the equipment failure, these are basically recovered or rectified through workover. And you can consider all these equipments, right? These are the actually waste generated during the well intervention process. And this is another picture. Well is completed with the sucker rod pump, and in the process of operation, the sucker rod fails. It got helical buckling. So another failure is we are doing a lot of light intervention with slick line or electric line, and in the process of the downhole condition or the equipment failure, the wire may be left in the hole, and sometimes it gets burnished and it obstructs the production. So with the workover, this failure is getting rectified. All this failed tubing as well as failed wire line getting recovered in the process. This is another failure, the casing getting parted, and the right hand side is the casing parted due to the formation movement. So there are various types of failures happens. Some examples in the process of the failure, that well is left with the fish, and I'm not going through individually, but yes, these are this is a list of some wells which is having sucker rod failures, tubing failures, right? So looking at this failure, you can very well understand that workover operation is not a simple operation. Workover operations are often complicated due to the following reason: complicated fish, and the fish is so complicated that well may not be able to kill. So well kill is a challenge. So you know that in order to do the workover operation, well needs to be killed. So sometimes because of the complicated fish, even the killing is a challenge. Parted tubing, corroded tubing led to complicated fishing operations. Sometimes during the production phase, the whole tubing is sanded up. So if the tubing is sanded up, then it is a complication. It arises a different types of complication because it blocks the tubing. So every fishing operation is unique. So it is not that we are doing a fishing operation and then the next fishing operation could be the similar. So no similarity. Placing the adequate barrier or BOP irrigab could also be difficult many times. Therefore, a thorough analysis is very, very important to formulate the well program. Workover operation is not similar to drilling operation, even though both deploy the rig. It is different. Drilling rig, it's a phase making hole, And there are different types of complications while drilling a well. Unknown environment they are going, whereas the workover operation has a different types of challenges. So in order to address all these challenges, to rectify the completion, this workover operation has been carried out. Now the other type of workover operation is to enhance the productivity, which we have talked about, right? Zonal change out, formation treatment, water shut-off, sand controls. So this is these workovers are carried out because the well having some issue with the production. Either the production is getting down or production is completely isolated, and sometimes the injection is having problem. To improve, so workover is carried out to improve or restoration of the reservoir performance. Sorry, just a minute. Somebody is putting the bell. Just a minute. Okay, sorry. To improve or restoration of the tubing's vertical lift performance. So what happens if we need to install some artificial lift, or sometimes the artificial lift is already there, but it needs the restoration. So workover is carried out to address this production problem. So any other workover purpose is the combating the problem associated with production, installation or replacement of artificial lift equipment. And now production issues are factors that affects the production performance. The reservoir pressure, the permeability reduction. Reservoir pressure could be declined over a period of time. The permeability getting reduced because of the production scheme or the injection scheme, or it could be the water cut or gas breakthrough. So example, some of the just pictorial representation of the issues. The increased water cut, so rise in oil water contact. So what is the solution for that? The solution is either mechanical shut-off of the bottom perforation. It could be mechanical shut-off or it could be chemical shut-off, but mostly if it is oil water contact is up, then it is mostly the mechanical shut-off. Then channeling behind the casing. Now if the channeling behind the casing means the cement is poured, so because of the channel, the water is getting migrated to the production and getting produced through the production perforation. So what is the solution for that? Squeeze cementing. Then there are some wells are completed with high permeability layers. There are different layers of the wells, and some high permeability layers are there along with the low permeability layers. Now what is happening if we have completed those wells, then the high permeability layers are getting produced first and the water getting produced. So how do you resolve those issues? By mechanical shut-off across the perforations or the chemical shut-off. Another increased water cut could be the water coning. So this could be chemically block the bottom perforation. So mechanical isolation, generally mechanical isolation, if we are having multi-zone completion, so bottom zone is producing, say for example, bottom zone is producing water. So mechanically, we can put the plug, the mechanical plug inside the completion, lower completion, and isolate. Sometimes a upper perforation, upper perforation is getting issues might be water getting produced or gas getting breakthroughs, and because of which the lower completions are not contributing. So this needs to be isolated. This can be isolated with a mechanical breeze plug or straddle packer completion. And in case of monobore completion, this kind of operation can be done with the light well intervention. It is not necessary that we need to deploy the rig all the time. So how do you do the chemical isolation? These chemical isolations, actually chemicals are, base fluid is low viscous and can easily be pumped and placed. And it forms the strong cross-linking gel once it comes into contact with water. You can see in this picture, that's bottom picture. And then fluid after coming contact with the hydrocarbon forms low viscous. So wherever the water is there, it will form a high viscous fluid, and wherever it is the hydrocarbon is there, then it will be a low viscous. So what happens in the process, that this is water and others are say oil. So chemical is getting injected into all the layers, but this will become solid and remaining will be low viscous and getting produced. Now this zone is chemically isolated. So now coming back to the vertical lift, artificial lift installation. So in a naturally flown well, this is a natural production well. So well is getting produced, well is having sufficient formation pressure, reservoir pressure, to lift the vertical lift as well as the back pressures from the separate surface facilities. So over a period of time, because of the product reservoir pressure declines, it needs artificial lift installation so that it assists the lifting in the vertical section. So one of these artificial lift is a progressive cavity pump. So progressive cavity pump is this is installed by doing a workover. So we lower the progressive cavity pump, and these are the cavity pump. PCP pump is being driven with the electrical motor, and this helps pumping out the formation fluid or the production to the surface. Another type of artificial lift is a Sakarot pump. So similarly, it is similar to both the completions are a bit similar. In terms of progressive cavity pump, it is a rotation with the motor at surface, and the SRP well is a positive displacement pump. So it requires positive displacement up and down. So it has the barrel is there, and this up and down movement is given with this bean pump. And in some cases, we may install the gas lift. So gas lift, you inject additional gas and it aerates the vertical column and the fluid getting produced. Apart from these ESP wells, there are some other forms. Plunger lift is there. And in some cases, the water, liquid, particularly in gas wells, the liquid loading is a problem. So the immediate solution could be put a vertical, velocity strain, so that we increase the velocity in the tubing and the formation fluid can be produced. Or in a moderately high GOR well, we may decide to install the plunger lift system. So plungers is getting installed at the bottom, and it is moving from the bottom to the surface, and with the piston effect, the oil is getting produced. And these are the different types of components installed in the plunger lift. Now we talked about the objectives of the workovers and what kind of workover is getting deployed. However, the workovers, in order to do the workover, we have to do certain steps, because in the process of workover, we need to pull out the tubing. And the well was producing oil, gas, or it may be water injection well, of course. So the well formation pressure has to be subsided, or a additional barrier needs to be put. So the typical steps in the workovers is first rig up the workover rig. Then immediate steps would be the kill the well. And how do you kill the well? We put over burden with brine or heavyweight fluid, which is heavier than the formation fluids, and it will ultimately it is decided in such a way that vertical head of the column is higher, and it subsides, or it overburden the reservoir pressure. And then we might need to do the additional barrier, because in order to carry out the workover, we need to remove the Christmas tree. The killing is the liquid barrier, but we need to remove the Christmas tree, and we need to put the workover BOPs and all. So in order to do the reinstallation of the BOP and removing the Christmas tree, we need to set an additional barrier, so that we have second barrier in place to protect the environment and to have the well control. Then we rig down the BOP, rig down the Christmas tree, and rig up the BOP. So BOP is a well control. BOP is blowout preventer. So it is a well control equipment. Then unset barrier. That barrier we have set in the step 3. This barrier is set in order to place this secondary barrier. Now this secondary barrier is placed, and then this barrier has to be removed. And then once it is removed, circulate the kill fluid and ensure that there is no activity, no influx from the formation. Then unset the packer. If it is optional, I am putting, because all the wells may not be completed with the packer. If there is no packer, there is no question of the unsetting the packers. If there is a packer, then obviously packer needs to be unset. And then the next step is the pulling out of the hole the upper completion. So once the upper completion is pulled out, then carry out the specific job. It could be the repairing of the lower completion. It could be breeze plug, putting the breeze plug, whatever based on the objective of the workover, as we have decided, or as you have talked about in the previous slides. So it could be the water shut off, or the perforation could be the additional objective. And then once this specific job is done, then run in hole again the final completion. And then when you run in hole the final completion, then set the barrier, rig down the BOP, and then rig up the Christmas tree. Once the Christmas tree is placed, then carry out the integrity test of the Christmas tree, pull out this barrier, additional barrier, and then activate the well. So these are the typical steps of the workover operation. Now, depending on the complexity, because they carry out the specific job, this is a bit. This is a not a typical thing, but there will be a detailed program. What job needs to be done? How it needs to be done? Sometimes now we say that kill the well. Killing could be a issue or challenging. So the detailed step-by-step program has to be carried out. But these are the, in nutshell, this is the typical steps of the workover. And this is just depicting, what kind of workover horsepower is required in order to carry out, different types of well. Like, all depends on what is the depth of the well. Why the depth? Because depending on the depth, your upper completion or any equipment you are putting into the well needs to be lifted out. It is to be pulled out. So weight will be increasing. And since depending on the depth, the weight will be increasing. So different types of drawworks power required for the different types of wells. So we can say, okay, 550 horsepower rig. So hook load would be, 150 tons. Like that, you can see the different capacity of the rig is depicted with the horsepower and based on the depth of the well. And also it is not only depth, also depending on the objective, what kind of operation we are going to do. Are you going to do a milling operation? Then possibly even the depth is 3000 meter, possibly 750 may not work. Then we have to select the higher capacity rig. Or we are going to do the side track. Then also, because it is side track is another kind of, it's a kind of drilling. So all these objective will, based on this, your capacity has to be decided. And this is the typical component of the workover. So workover rig, generally workover rig is a mobile rig. It is mounted on a truck, and the power is given through the diesel engine. It is a traveling block. The mast is getting erected. This is one type of mast with a telescopic mast, basically. So drill lines, crown blocks. This is the typical, just a few components of the workover rig. Now, coming back to the well killing, as I said, why do we need to kill a well? To ensure that well does not flow while working in the well. So this is the formation. Formation pressure is always try to give the upward force, and with this fluid, hydrostatic pressure is giving the downward force, and this hydrostatic force pressure has to be, hydrostatic force actually ultimately load has to be more than the formation pressure. So well kill could be by different method using, depending on the various factors. It is what kind of the well, is it an oil well, gas well, how is the permeability? If the permeability is very good, it is a gas well, straight to a bullheading could be the option. But if it is an oil well, permeability is not good, and then viscous oil, then this needs the circulating killing well, circulation process. And depend also the type of completion, what type of completion we have. Is it a packer completion? Is it with or without SSD? Because this is SSD means sliding side door. So by opening this, we can establish the communication between tubing and casing, and then circulate the kill fluid from one side and completely displace to the annulus and get the return. So the type is, it could be bullheading if it is a very high permeability, or it could be bleed and loop method, or it could be circulation kill. And always in the workover, always, it's not like drilling, always use the clean brine, because this brine is going to be lost some of those will be lost in the formation. So we need to have a clear brine so that we do not damage the formation in the process of killing. And kill weight depends on the different types of the salt. And in case of sometimes what happens, the well is having the low pressure, and then it has a fluid loss is a issue during the killing. Then we have to use the circulation loss fill. So now this picture denotes the well on production. You can see this blue section talks about the barriers. This is the primary barriers. What is the primary barriers? When the well hydrocarbon is always in touch with those barriers. When the well is getting produced, this is getting produced, packer, it is getting protected by the packers, then it is getting produced through the tubing. So tubing is a barrier, the whole wellhead is a barrier, and it is getting produced through the production wing valve, and these are the barriers because this is the closed. Now, in order to carry out the workover, as I said, we need to place, we are changing the barrier. So we are actually displacing, we are removing this barrier. So if we remove this barrier state, what will happen? It will produce, and this will be a uncontrolled flow to the surface. So in order to protect or control the production or not to produce during the well workover, we need to place additional barrier, and that is what the kill fluid. And so kill fluid is pumped through this killing valve and displaced whole wellbore with the kill fluid. So now we place this barrier, and once we place this barrier, we can remove this. We also place one more barrier. Actually, this is the mechanical barrier. So once we place and confirm this barrier's integrity, then we remove this Christmas tree and immediately we put the walkover barrier. What is the walkover barrier? Is a blowout preventer. So this blowout preventer is getting installed, and once the integrity of this blowout preventer is ensured, then this primary barrier, the mechanical barrier is removed, and then we can remove this tubing and all packers and everything and do the walkover operation. So this is what, in nutshell, the barrier concept in a walkover well. I am okay. I am depicting. I mean, showing one of the incident you all might be familiar, or definitely I'm sure you are all familiar with Bagjan well number 5, which occurred in 2020 May. So what has happened? Actually, there was a barrier failure. So it was a walkover operation. What was the job objective? The objective was to repair the wellhead. So they had the issue with the wellhead. So they deployed the walkover rig in order to repair the wellhead. So they have to change the well status from the production well to the walkover well. Now, what do I mean by that? This is a production well, so status is the production well, and this is a walkover status. So this needs to be changed to this status by doing the process in between. Okay. So change the well status from the production well to the walkover well. So Xmas tree was nippled down, BOP placed, walkover operation commenced. Then they placed the barriers in order to repair the wellhead, or in order to work on the wellhead. At least 2 mechanical barriers to be installed and confirm their integrity. uh, it is uncertain, or I cannot comment whether all the barriers were in place or was those barriers tested, and they have commenced the work on the well head, and the incident happened, which means the barrier what was placed is failed, and the disaster's catastrophic consequences. So we all know that. So workover is not a simple operation. We need to understand the completely the barrier concept, at what stage or what type of barriers are in place, and not only place, we need to ensure and confirm that integrity of the barrier, that barrier place is working for the objective for which it has been placed. So the result was the catastrophic. You all know what was the consequences. I'm not going in details, just showing some pictorial representation of the disasters, and these are the consequences if the well intervention are not planned and executed the way it should have been. So now I'll talk about a little bit of the waste associated during the workover operation. As I have said, a lot of waste has been generated and have been shown by pictorial representation with the tubings, the failed sucker rod, uh, the failed downhole completion. Those are waste generated during those workover operation. Apart from that, during the workover operation, we are using brine or the kill fluid. The kill fluid is a primary barrier, considered as a primary barrier. So those kill fluids are getting returned in the process of doing the workover, and those are actually waste. And those workover fluid consist of a lot of hazardous salt, potassium chloride, calcium chloride, sodium chloride, and it also consists of some hazardous chemicals as additives, like corrosion inhibitor is put normally. Cross-link gel needs to be added. So chemicals are added, the hazardous chemicals are added, and sometimes in order to carry out the formation treatment, the acid are being used. So those are also the hazardous fluid, and all these things are getting produced as a return fluid. On top of this, those are the induced, we know that we are going to put this chemical. And additionally, the return fluid also contains the well fluid. So, okay. So, well fluid is consisting of the hydrocarbon, the carbon dioxide, the hydrogen sulfide gas. All these are actually waste produced along with the return fluid during the workover. So what is the consequences if it is not handled properly or not managed properly? Because the severity of the or the complicacy of these hazards these are toxic. This is health hazard, environmental hazard. And if not contained properly, it may spill to the nearby areas, creating environmental issues. And it may contaminate the drinking water or the river water, so animal may drink. Non-degradable matters like hydrocarbons and all can create soil contamination, effects on agriculture produce. And if it is not contained properly, it may contaminate even the groundwater. So the management of this waste is very, very important aspect during the workover operation, and proper waste management needs to be deployed, including effluent treatment plant. So you can see this is a typical rig site. It is both, you can see workover rig as well as the drilling rig, and these effluent are getting they're getting returned into the effluent treatment plate. And construction of the pit also a one of the management process. So with that, I think I'll complete the workover part, and then I will jump into the light well intervention, which is rigless intervention. And before going to that, I hope my presentation is clearly audible. I just wanted to get a feedback, or Mr. Dr. Neog.
Yes, sir. It was audible and loud, sir. Thank you.
Okay, all right. Thank you very much. So I just wanted to have a cross check in between because, okay. So next part of the presentation is a light well intervention. So what are the light purposes of the light? Sorry, light well intervention. It started with the well commissioning. When a well is getting drilled, at that time well needs to be commissioned, and we need to deploy the light intervention in order to remove the barriers, in order to activate the well. Sometimes do the coil tubing, nitrogen activations and all. So this is well commissioning. At the time of well commissioning, even the integrity test before putting into the production, the whole health of the well needs to be identified, needs to be diagnosed or tested, and these are the purpose of light intervention during the well commissioning. The second purpose is a well surveillance. So we need to carry out the surveillance activities in order to gather the data. How my formation is behaving. What are the different parameters, change in parameters. So we need to carry out a lot of well surveillance activities. Say for example, we are completing a multi-zone completion. We are producing simultaneously. So we need to identify, suppose water production is an issue or gas breakthrough is an issue. So we need to carry out the well surveillance activities, carry out the, say for example, logging activities, production logging. It will tell us the contribution from the different zones. So this is another objective of the light well intervention. Then the preventive maintenance. Now, with the light well intervention, we can do the preventive maintenance of the well. It could be the upper completion, it could be the lower completion. Then the production enhancement. Even it is not necessarily that production enhancement can only be done through the heavy workover, heavy intervention. It can also be done with the light intervention. It could be with the stimulation, it could be with the additional perforation without deploying the rig. Another purpose is the integrity investigation. So well integrity is the health, indicates the health of the well, and we need to ensure that all the barriers and components are intact, and we need to do the preventive as well as corrective preventive investigation as well as corrective maintenance. So these are done with the light well intervention, and the corrective maintenance, as I said, it is a well repair. So left hand side is the well diagram just I'm showing. It is the rigless intervention versus rig intervention. That means the light intervention versus the heavy intervention. So in the rigless intervention, the well is generally all the operations are performed in a live condition of the well. So well is not getting killed. So live well intervention. So barrier concept in the production phase, barrier concept in heavy intervention, barrier concept in light intervention are completely different, and one need to be very one need to have the good thorough understanding of these barriers, so that he or she can plan and manage these operations. The presence of casing, liner, production string provides flow paths to the formation fluid to the surface, and because we have the metallic completion at the bottom or in the well, so it is less likely to breeze off in case of blowout. So what happens in the drilling? While drilling, the downhole completion are not in place because they are drilling and they are going to put the downhole completion, and in the process of the drilling, if in case a blowout happens, then most of the times, or not most of the times, a lot of times, we can say that this hole gets collapsed because there is no casing. So the hole gets collapsed and the hole gets breezed up, and blowout can be stopped downhole, or sometimes you can do additional drilling. But in case of light intervention or any intervention, because already all these protections are there, so it is less likely getting breeze off will not be happening unless the lower completion is completed with barefoot completion or without having any completion. So I put that what is the example? Can you find out that example? Yes, the example, the blowout happened and it was not getting breezed up automatically, so had to do the additional intervention, which is the Bagjan pipe incident itself. And there are invariably a greater degree of non-routine operation are performed during the well intervention works. So it's no well intervention. Yes, there are similarity, but you cannot compare apple to apple. So we call it is a non-routine. It is not routine job. So every program has to be thoroughly identified, thoroughly analyzed, and program has to be made. Since the existing regular well barriers are compromised, existing regular well barriers are these casings, downhole barriers, the cement, in the top, the Christmas tree, the wellhead. So since in the process of doing the well intervention, so some of the barriers are compromised. So those barriers are no longer valid during those operations. So, or those are made non-functional. So we'll talk about that. Say for example, swap valve is a barrier. During the coil tipping operation, swap valve cannot be closed. So the barrier, that barrier made non-functional. So we have to have the additional barrier placed to ensure that blowout doesn't happen or uncontrolled flow doesn't happen. So additional well control equipments are to be installed to intervene these wells, and those equipment are called pressure control equipment. I'll show some of the pressure control equipment down the line once going through the presentation. So well intervention is carried out. Say for example, one of the well intervention is carried out with the pumping and stimulation unit. So you can see this is a pump, and I am just showing only one pump over here. This pumping, with the help of this pumping unit and with other equipment, we can do the lot of well intervention. Say for example, the left hand side showing this formation. So as you know, this fluid are getting produced through the formation, through the pore spaces, right? And it is getting produced. Now, if those pore spaces, I am analyzing this, if these pore spaces are partially or totally blocked with the scales, so these scales needs to be removed. And with the stimulation by pumping the right kind of treatment fluid, maybe acid, maybe scale squeeze treatment. So we remove this and clear it. So now you can compare from top to this or top to this. You can see the permeability is increased. So well productivity will be increased. So this is one of the well intervention. So what are the generally what are the what type of jobs are performed with this pumping unit? The well integrity pressure test. So that is a diagnostic operation. Acid stimulation, as I have shown in the previous picture, the acid stimulation. So it could be bullheading, acid stimulation. Why I am saying bullheading? Because there are, if we are not doing the bullheading, then we have to utilize the coil dipping. So that is a different types of equipment. Then high rate water shut-off job. Sometimes in order to carry out the chemical shut-off jobs or sand consolidation, we can do the high rate water shut-off job with the help of this pumping unit or the stimulation unit. A high volume scale squeeze job, hydraulic fracturing. So in order to fracture the formation and pump the propellant and make the connectivity more, we do the hydraulic fracturing. We call it hydraulic fracturing, and that can be done with this stimulation pumping or stimulation unit. Then frac pack, in case of the sand consolidation job or the frac pack job, this pumping unit is being used. These are the typical general objectives, general jobs. So so what are the equipment required? So we have to have the high pressure, high volume pump. So the pump has to be capable of pumping the desired fluid, designated fluid in a high volume and against the high pressure. It could be 10,000 psi rated pump or 15,000 psi rated pump. It could be required to pump, say, 5 barrels per minute, or depending on the job design. So we need to have a chemical or acid tank where we store these chemicals, and from where this operation this pump get suction, pump is taking suction and pumping into the well. So this is another equipment. And high pressure irons, the stroke manifolds, these are, or the diverter manifolds, these are the equipment requirement. Safety relief valve, always we have to equip the safety relief valve in case of emergency. That safety relief valve gets released and popped up so that that emergency can be stopped. Say for example, you are doing a fracturing operation and hydraulic fracturing operation, and it is a sand screen out. So if we do not have the safety relief valve, what will happen? The whole well will be exposed to additional high pressures, high load, and even whole well gets damaged. So safety relief valve. So we need to have a batch mixer to mix the chemicals, different chemicals. It could be acid, it could be acid mixed with waters, and then corrosion inhibitor fluids, or sometimes that cross-link gels and etc. So batch mixer is required. And in case of fracturing operations or the frac pack operation, the sand silos and hopper system will be required. And the blender will be required in order to do the frac operation or the hydraulic fracturing. Then data acquisition system, so that you monitor all the data parameters and your operation is going smooth. And obviously, you have to have a control panels and ESD system. Those are the equipment required for the pumping operation or stimulation operation. And you can see from this picture, those equipments are laid out. So these are all the pumping pumps, all mount. Of course, the trailer mounted pumps. These pumps are. This is a huge hydraulic fracturing operation. So these are the pumps. Then you can see the tanks, the silos. All these equipments are laid out, and the whole, you can see the whole plinth is totally busy, and it is not it's very simple process. Lot of planning, lot of risk mitigation analysis needs to be carried out. So this is a typical hydraulic fracturing operation onshore. And this is just a block diagram, the same thing. So next is that coil tubing operation. Sorry. Sorry, just let me take some water. So coil tubing operation. So this is another type of light well intervention. The picture depicts the coil tubing unit, onshore unit. You can see generally in a onshore operation, the coil tubing equipments all are mounted in a trailer, one trailer or maybe multiple trailers. And what is coil tubing is actually, it is a coiled. You can see this is a coil, and coil is getting intervened into the well by deploying all this pressure control equipment. And the right hand side, this is offshore. This is the offshore platform, and there is a barge. This is actually vessel. A lot of equipments are kept in the vessel if there is no place to put on the platform, and some of the equipments are getting lifted to the platform. So this is the injector head. It's a similar kind of injector head, because the injector head injectors always had to be installed on the wellhead, and the coil tubing has to be, of course, in the platform. Or sometimes the coil tubing also getting deployed from the barge itself. And then if there is no place, not much place, then all other equipments are kept into the vessel, and it is connected to the platform or the well through Coflex hose, and the operation is getting done, and it is not very simple. Like, I would not say this is also simple, but this is more cumbersome in compared to the onshore operation, because some of the equipment, some people are on the platform, some are in the vessel, and there has to be very good coordination between them. And sometimes because of the sea roughness or sea swelling, this equipment will be moving up and down. So generally the bar is used with a dynamic positioning, so that it keeps steady on the water. It can go up and down, but it will not go away from the location. And a lot of other safety precautions has to be taken. So coil dipping operation, what are the jobs we do? As I said, well commissioning at the first when the well is getting commissioned, then well needs to be activated. So that well activation is done with the coil dipping with the nitrogen application, and even after workover also well needs to be activated. Not necessarily always, but sometimes. So coil dipping operation is coil dipping unit is getting deployed to get to carry out the well activation. Then in the well bore is in the process of production. Well bore in the downhole is deposited with wax, sand ingression in the well. There are scale deposition in the well bore. So all these are to be cleaned out. So this can be done with the coil dipping by deploying the coil dipping unit and coil dipping operation. Formation treatment, as I said, in the pump with the pumping, we have to do the bullheading treatment. But with the coil dipping, you can just go and spot against the formation and carry out the formation treatment like acid wash or matrix stimulation or whatever it is. Then reservoir penetration for productivity improvement. So for productivity improvement, there are other type of requirement may arises, like you need to have a small holes inside the formation away from from the link to the tubing. So the radial drilling can be done with this coil dipping operation. Even the drilling can be done, well bore extension can be done, well can be sidetracked with coil dipping operation. Completion equipment manipulation, which means that a lot of times you have a lot of sliding sleeves installed either at the formation phase, the lower completion, or even the upper completion. Then there are frac sleeves. There are multiple zones are to be fracked and then completed with the frac sleeves. Those manipulation downhole frac sleeve manipulations or the siding sleeve manipulation can be done with this coil dipping. Apart from that, jet pump removal, gas leak valve change out can be done if it cannot be done with the Y line. Sometimes it is not possible because of the high deviation, high dogleg severity, and mostly in the offshore wells. What happens in the offshore well, because a lot of wells are getting drilled from one platforms and high extended formations are reached to the completion. So on those kind of wells, wireline may not reach to carry out those operations, and that can be done with the coil dipping operation. Production logging, well surveillance activities, production logging, and then other corrosion loggings and all other well surveillance activities like pressure temperature surveys or noise surveys. All these kind of operations can be done carried out with the coil dipping operation. Then setting the breeze plug, the mechanical isolation we talked about earlier during the well intervention when there is a monobore completion, or even the tapered completion also with the inflatable breeze plug. This breeze plug setting can be done with the coil dipping. Then retrieval of the breeze plug, milling operation can be done, fishing operation can be done. Those are the operations done with the coil dipping, and then cementing. So typical coil dipping rig up. I'm showing this onshore coil dipping rig up. So this is the bottom is the well. This is the production well. We are not removing all the barriers. However, we are installing additional pressure control equipment. The BOP have to have the stripper. That is the primary barrier. The lubricator, the injector head, so that coil is getting injected or inserted into the well. Now, when we insert this coil into the well, then some of the regular barriers, the Christmas tree valves cannot be operated. And that is why these additional barriers are to be placed. And this is the coil and the control cabin. This is the pictorial diagram, and instead of, because these all valves are now no longer can be operated with the these are non-functional basically. So additional barrier in terms of blowout preventer or the lubricators or the steppers are installed. This is called the pressure control equipment. So this is coil tubing operation, and this is the coil tubing cabin. All these operations are getting controlled from the control cabin. So this is, you can say, this is the heart of the whole coil tubing operation. Okay, so during the running in hole, what is the depth, what is the weight, what is the pumping pressures, all these are getting monitored and controlled, and necessary corrective action needs to be done. Now, the wireline operation. So we have two types of wireline. One is called electric line and other is called slick line or braided line. So this is a slick line operation. So again, you can see the well is there, and then the pressure control equipment is being rigged up, and slick line is getting inserted into the well for surveillance or the jobs for which it is objected. Now, this is another type of wireline operation. Say, for example, logging operation with the electric line. Okay, so what are the operations with the wireline we can are carried out? Generally, broad range. The reservoir management. So pressure, temperature survey, those are the surveillance activities. Flowing gradient survey. So in order to know what are the gradient in the vertical column, and is there any water loading, or it is a uniform gradient, or what are the gradient, so that you can accordingly, based on those informations, you can suitably design your artificial lift system. Then fluid sampling. Then if the well is getting produced sand, then that for the reservoir management purposes, we have to collect the samples. So this wireline, with the wireline operation, we can collect these samples. And PLT or MPLT. PLT, when it is a E-line, it is PLT. When it is a slick line, this is a memory mode. So it is MPLT. And then well integrity, the other purposes is the well integrity control. So well integrity and investigation. So we are done with the wireline depth measurements, and then caliper survey in order to identify the diameters or uniformness of the tubings and all. Then we also, in order to do the integrity test, we need to set the plug. Flow control operations like manipulation of the sliding sleeve and shutdown tools. Those are the operations done during the well integrity investigations or control. Downhole shut-in valves, and also downhole video camera. Sometimes we run in downhole video camera to visually capture the condition of the wellbore. Then corrosion logging. So these are the jobs broadly under the category of well integrity control. Then remedial or rectification or improvement activities like fishing operation. Now in the process, if there is a fish, then we have to rectify that. So with the wireline operation, we can do the fishing operation. wax scraping, scale cutting, all these operations are getting done with the help of wireline operation. Then dumping cement or dumping sand. Sometimes we want to dump sand or the wellbore or dump cement to block a leaky, say for example, leaky breeze plug. So that can be done with the wireline operation. Backup assembly setting also can be done. Breeze plug setting. All these remedial or improvement job can be done with the wireline operation. Artificial lift operation, gas lift valve change out. Swapping operation. Swapping is a operation of well activation. Jet pump installation and removal. Plunger lift installation and removal. A PLT survey for a gas lift valve diagnostic operation. So these are in the broad category of artificial lift. Then electric line, we can do the perforation. Of course, we can also do with the slick line also perforation, but slick line perforation, the depth correlation would be not exact and as it doesn't have that surface readout, so it has to be in the memory mode. So for the electric line, you can do the perforations, logging operations, cement bond log or variable density log, saturation logging, water saturation logging in the formations, plug setting, then advanced robotic tools. Sometimes we deploy the advanced robotic tools to carry out the certain downhole operations, corrosion logging. Those are coming under electric operation. And obviously there are some other wireline is a fiber optics operation, which is downhole, permanent downhole gauges and production monitoring. So these are the wireline operation. And now coming back to the wireline sizes, there are mainly two types of wireline is used for a well intervention. One is non-electric type. So non-electric type is a slick line, you can see in the picture, and it could be the braided line. So the other type is the electric line. So electric line, with the help of the electric wire line, we are carrying out the downhole operation, and we are simultaneously recording or observing all the data at the surface. So have to have the electric conduit. So this is the configuration, the outer armors, inner armors, and inside the electric conduit is there. And with the help of this, we do the various electric line operation. And the slick line sizes varies from 0.0 to 7 inch to 0.160 inch sizes. And most commonly used sizes are 0.092, 0.105 or 125 sizes. Braided line or both electric line is also a braided line. So braided line, electric or non-electric, could be 3/116, 1/4, 5/116, 7/116. So these are the sizes. And as I have already said, that electric line provides the surface readout and facilitate the real-time monitoring and control. And use of different types of the wireline are different purposes, as we have already talked about. And this is the some of the component electric slick line unit component. So this is a slick line unit, the toolbox, the control cabins, and this is the rig up. So this is Christmas tree, and on top of the Christmas tree, BOP is rigged up, the pressure control equipment, the stuffing box, and this hay pulley and the crown pulley. and the wire is getting, and this is connected to the unit. This is the previous one was the skid mounted unit. The same is in the truck mounted unit. Everything is mounted in a truck. Another type of well intervention is snubbing or hydraulic workover unit. So this is also a well intervention unit is carried out in a live well. The completion or the tubing is snapped into the well without killing the well. What are the snubbing operation? Snubbing is a heavy, we can say it is not very light well intervention. It is actually a workover. It is a heavy well intervention, and it is performed in the oil and gas well in a live condition. Snubbing units are designed to run the pipes in and out of the well under pressure in the live condition. And the unit can be rigged up very quickly because it is not a conventional unit. It is the rig up is very fast, and snubbing unit can perform most of the operation as being carried out by the conventional rig or workover unit. Certain safety issue must be addressed because of the small pipe size use. Because workover, you are replacing whole completion tubing, and the snubbing, either you are replacing the whole completion or you need to do the snapping with the smaller size of the pipe. And this unit can be used for drilling workover in a live condition. Snubbing application. Snubbing is pipe raising, lowering operation where specialized equipment is used to overcome the forces trying to push the pipe out of the hole due to the certain wellbore pressure. So when a well is shut in, then the the well is certain well pressure is getting accumulated, and then when we try to snap in against those pressure, the downward pressure will always try to force out. So the operation in the snapping operation, it has to be against those pressure. In the well where due to the production issues that requires the well needs to be worked under pressure, sometimes workover cannot be carried out or should not be carried out because the well formation pressure is not very high. And if you do the conventional workover, then what needs to be done? The well needs to be killed, and that formation, a lot of time the formation gets damaged, and in the process, even well recovery could be a issue. And we face a lot of issue with the well recovery and the formation rectification. So with the help of snubbing, without killing the well, the snubbing operation can be carried out and do the workover. So running and pulling the string, resetting, weight on packers, fishing operation, cement squeeze, perforation wash. If the perforation is blocked with say sand or some scales deposition, so perforation can be washed. Installation of the velocity string, as I have said or shown in one of the pictures, that water loading the gas well is not getting produced because of the water getting loaded. The tubing size is bigger, maybe 4.5 inch, 3.5 inch. So with the help of snubbing unit, without killing the well, a velocity string can be installed, and then production can be revived. And obviously, well control operation, as you have, you must have heard in a Bagjan of Bagjan well control operation was carried out by using the snubbing operation, snubbing unit. So this is the typical snubbing unit components. I will not go through all the details because a bit complicated, but yes, in nutshell, the control unit is there. There is a traveling slips, so it is getting traveled in the process of snubbing. So hydraulic cylinders are there, and this is the telescopic mast, and there is a stationary slip. So stationary slips is always station, remains in the same position, but in the process of snubbing, this section is getting up and down. Then tubing strippers or annular preventer, and the BOP stack is there at the down. These are all installed on the top of the Christmas tree. So this is just depiction of how the tubing is getting snapped in, which ram is getting open and closed. So this is a coupling. So this is the stationary blocks. So this ram is open and the bottom ram is closed. Once this is coming inside, then this ram gets closed and this ram have to be open so that this coupling goes, or downhole equipment goes past through, snap in, and that is how the whole process. This is the snap in and snap out. This is the snubbing unit pictorial representation of the offshore snubbing unit, and right hand side is the onshore snubbing unit. So now this is I have almost covered the unit with which the operations are carried out, as well as the purposes of the operations. Now, in order to understand the environmental effect on the environment or waste generation during the process of the well intervention, we need to understand certain hazard, or we need to understand the following things. So what are the hazards associated with wells or the intervention? So if we do not understand clearly the hazard associated with the wells or hazard associated with the intervention, then we will not be able to successfully not only successfully carry out the operations, we will also not able to protect the environment. And if we do not understand then consequences, we also need to understand that what are the consequences. As we know, in case of blowout, well blowout, what are the consequences has happened. So we also need to understand the barriers. What are the different types of barriers during the production phase and during the well intervention phase. So, and then when you carry out the well intervention operation, we also need to know what are the any other effect on the environment. So hazard associated, so I'll just briefly talk about some of the hazard associated with wells and the intervention. Number one hazard is the pressures. What are those pressures? The formation pressures, the pumping pressures. So wellhead pressures, then temperatures. The hydrocarbon fluid itself are the hazards. Oil and gas are flammable. Then hydrocarbon formations also associated with getting produced with the H2S, carbon dioxide, even norms naturally occurring radioactive materials also getting produced. All it depends on the formation characteristics. So these are the norms is like, say, for example, barium sulfate. So it is naturally occurring in the formation. So these are the hazard associated with wells. And intervention fluid, like the fluid we used in the process of well intervention, is the acid. We used a lot of other chemicals. Those are the hazardous chemicals. And of course, when we carry out all these intervention, the return fluids also carry out these hazardous chemicals. So we need to understand, and these are the hazards basically. We need to understand on this. So this is during the coil dipping operation. If the equipments are not properly maintained, the incident might happen. This is the incident has happened during a coil dipping operation where the primary barrier stripper fails and the gas getting leaked, and in the process of friction, it is getting ignited. So equipment has to be properly maintained, and all the operations, during the operation, it needs to be monitored. And in case of any uneventuality or anything abnormality is observed, then the other secondary barriers needs to be activated, like blowout preventer. I will not go through this video because it will be long. So another one is during the pumping. So during the pumping operation, the pressure is a hazard. So if the equipments are not fit to the purpose, then this pumping line gets burst, and you can see the consequences. And then during the fracturing, again the same thing, that during the fracturing, the very high pressure is associated. If the equipments are not monitored properly, not maintained properly, the incident might happen during the operation. Then the temperature itself is a hazard. As you go deep and deep, the well fluid is the temperature is high, and you produce the well. Then the whole wellbore equipment is exposed to the higher temperature. Then during the well intervention, then we inject the cold fluid. Now, when you inject the cold fluid, the cold fluid again cool down the completion, which is already set according to the geothermal gradient. So there is a stress, induced stress during this operation. So temperature changes during the production as well as during the intervention operation induces the stress in the equipment, and as a result, the fatigue happens. As a result, completion failure might happen. And if it is the concentration is more than 10 ppm, then it's really dangerous. With the 10 ppm, we can work up to probably 8 hours, and beyond that we cannot work. 15 ppm maybe 2 hours, and beyond that 50 ppm immediate irritation in the eyes, and then 100 ppm it is killing, fatality. It is corrosive. So H2S corroded the pipes. So in the process of the production, the tubing gets corroded, casing gets corroded, and it is also flammable. If you burn the H2S, the more toxic fluid is generated, which is sulfur dioxide. So apart from health hazard, H2S is also an odor hazard. It is creates a lot of public nuisance. So less than 10 ppm is a green condition. You can work up to 8 hours with a possible danger. 10 ppm is to 15 ppm about 2 hours, and beyond that it is really dangerous. Norms: necessarily occurring radioactive material, barium sulfate, say for example. Then the stimulating fluid, itself is a hazardous acid, xylene, so as well as a return fluid. So this creates radiation. This is biological hazard. This is poisonous as well as corrosive. So we need to understand this hazard associated with the well fluid, hazard associated with the treatment fluid. And this is a slide talking about the waste generated in the well intervention operation. Type of the waste is the return fluid. So when we carry out the well intervention with rig, workover, or oil tipping operation, the return fluid consists of hydrocarbon. Return fluid consists of the formation water, which is saline. It could dissolve, with the H2S or carbon dioxide or norms. And additionally, it also consists of solid sands and the scales. So these are the hazardous to the life and the environments, flammable, the hydrocarbon, the H2S. These are non-degradable fluids, and this degrades the soil condition. Possible contamination to the water. These are corrosive, radioactive, and the solid generated in the process of the well intervention can create the soil contamination. So this needs to be treated and handled properly during the operation. Then the brine used in a workover operation, it consists of this kind of salt, and it obviously is soil and water contamination, create pollutions, which is deadly for some of the fish, for freshwater fish, because freshwater fish are not suitable. I mean, they cannot survive in the salty water, salty environment. Even it is poisonous for the animals. Stimulation fluid, acid, is corrosive. It is health hazard, toxic, poisonous. Then bailed out samples. When you carry out the sampling from the well to identify, to know what is the issue in the downhole, we carry out the sand. We bailed out the scale, we bailed out the norms, we bailed out the hydrocarbon. Those are the waste generated during the bailed out operation. And the solid waste sand may not have much major effect, but it has some soil contamination, but it is radioactive, so it has to be dispersed with a proper radioactive disposal manner. And cleaning, and crew used a lot of cleaning materials, gloves and then racks and all this stuff. All these are the solid waste and needs to be handled properly. So if those are not handled properly, if it is spilled, even oil, it is a production, but when it is spilled, it is a waste, right? So it creates the environment and serious effect if the oil spill happen. And these are the consequences to the life, to the vegetations, and last picture is the flame and the fire. So effluent pit used in a drilling fluid or in the workover. What is wrong with this system? This system, you can see the return fluid is deposited in the effluent pit, but this, what is wrong? This pit is not constructed in a proper way. So what happens? The soil contamination, ground is getting contaminated. If this pit is not constructed properly. So, and also it is a environment. It creates a lot of issues with the environment. So, what is the right way? Right way is to pit has to be constructed with the lining. So these are the liner. So you put the all returns in the pit so that it is not getting contaminated to the solid. The water gets evaporated. Solids are not getting contaminated to the nearby areas, and it is getting deposited, and proper waste disposal can be done to dispose those dry out waste. Okay, now in nutshell, how to stop the environment, how to stop the incident during the well intervention effect. There are the technical barrier. So what are the technical barrier? The well, during the process of the well intervention, the right equipment are used, the right pressure control equipment are deployed on the top of the Christmas tree. So these are the technical barriers. Say for example, this is coil tripping. Stripper is a primary barrier, BOP is a secondary barrier, shear seal BOP is a tertiary barrier, and these are installed on the top of the Christmas tree. Then comes the operational barrier. What is the operational barrier? The procedures, the work program. The program has to be made in such a way that we all follow the standard operating procedures, so that there should not be any shortcut. Do the right steps one by one, depending on the hazard associated, the consequences associated. So that is called the operational barrier. You have to have the technical barrier in place. You have to have the operational barrier in place. And the third one is the organizational barrier. So what is the organizational barrier? Is a competent people. So we need to deploy the competent people, right people in the right place. They are trained. They know how to do the job, how to check the equipment, how to operate the equipment, and how to follow the program. And if all these are taken care of, then no incident will happen. Anything else, if the technical barrier fails, still incident may not happen. If your organizational barrier, operational barrier are intact, you can immediately control those failed barrier, and that is why there are multiple barriers in place. And if this technical barrier fails, operational barrier fails, and organizational barrier fails, then the hazards is exposed to the environment and incident happens. I think this is 12:47. So this is actually end of my presentation. How did I do with the timing, Dr. Neog?
You are on time, sir.
Okay, so this is end of my presentation, and then if there is any questions or anything you want to go through, we can have some time. Yeah.
Thank you, sir. Uh, it was really a very engaging and detailed session. Uh, Let me check if there are any questions in this chat box. So one question is from Abu Libda. Uh, Actually, no question is praising you. Very comprehensive and informative, sir. Thank you very much.
Thank you.
Participants, if you have any query, you can unmute yourself. Thank you, sir. For if no more questions, let me thank sir. Thank you, sir, for joining us from Muscat, and in spite of your busy schedule and professional commitments, thank you for your sharing vast knowledge with us regarding various workover operations, light and heavy, and about the controlling of coil tubing operations, snubbing unit, well commissioning system, production system, artificial lift systems. It was a pleasure listening to you from a person who has vast experience and who has worked in many organizations, in many ENP industries. I have gone through your resume just now. You have vast experience of working for long 16 years time in Oil India Limited, 2 years in Kane Energy India Private Limited, 4 years at Oman, 10 years at Vedanta, 1 year in Sales Oil Services, and currently you are based in Susco, Muscat. So it was really a pleasure listening to you, and we have been benefited as usual uh, from your speech. Thank you, sir. Thank you
Thank
once
you very
again
much.
for your help.
Thank
Thank
you
you.
very much for giving me the opportunity. It is my pleasure, and my university from where I have did my bachelor's of engineering, Jorhat Engineering College under the Dhrubajyoti University. So it is my always pleasure to be associated with the university and not only the faculty as well as the students. I am always open, and I would like to share my knowledge with the upcoming generation so that we continue our knowledge sharing and development in the process of in terms of industrial development, in terms of the people development. Thank you very much for giving me the opportunity.
Welcome, sir. Welcome. Welcome. Welcome.
So then, with that, I can leave the session. I hope you
Yes, sir.
are
Yes, sir.
benefited to at least to a certain extent. And Dr. Neog, I would be happy to receive some of the snapshots and the videos of this
Okay, so I
session.
actually forgot. So, dear participants, I would like to have a photograph with our resource persons. You are therefore requested to kindly turn on your videos so that we can take a group photo session, have a group photo session with our resource persons. Participants are requested to turn on their videos. This also. Thank you all for joining us in this session. Sir, I will
Thank you
mail
very
all
much.
these snapshots as well as the video.
Thank you very much. Thank you once again.
Welcome, sir. Welcome,
Okay.
sir.
Okay.
Welcome.
Bye for now.
Bye, sir.
Thank you.
Bye. Bye. Thank you.